So the compact model is going to be using a few new innovations, but how will they actually work and why has no one done it before? It seems there were some missing pieces in the technology. So I found this pretty fascinating post on X by John Twigge, and I managed to blackmail him into joining us. Let's find out what he's got to say about this. I'm Brian. Welcome to Future Oza. So, John, you have a background in software. What's that about?
So first of all, I want to say thank you, Brian. It's really good to be here.
Yeah.
Thank you for talking. Uh, Software. I don't like software. I've
It's
just always
difficult.
written software because I like what we can do with it. So we can do all sorts of clever things with software. So I was fascinated by where that's going. And of course, at the moment, it's going big places very quickly with artificial intelligence and all sorts of things. So, yeah.
It's very important. It's arguably the most important part of the car, and other manufacturers have found how incredibly difficult it is. And when Volkswagen put their Cariad group together and said, we're going to hire 10,000 monkeys at typewriters to see if they can come up with accidentally good code, they found that they did not have infinite time, which is what it would have taken. What a mess that was. So in the model, the compact model, there were some missing pieces, and I've covered the hardware issues in the past, one being that the reason you couldn't put a compact together the way they wanted to, I talked to engineers about this. They said, well, the first problem is with unibody construction, you can't build a modular car. It is unibody. But even if you could, with front and rear castings and a structural battery, you still have things that need to run the length of the car. The wiring harness, the hydraulics. Well, with steer-by-wire and brake-by-wire, you get rid of the hydraulics. And with the 48-volt architecture using essentially Ethernet connections, you can get rid of the full-length wiring harness. But there's other pieces missing, and that's what we're going to discuss today. So here's the tweet. This will be the post, I guess I should say, so I don't get in too much trouble. I will be linking this in the description, of course, and this was posted a few days ago by you. So Autoline went ahead and covered this topic, and they broke down a lot of the manufacturing benefits with the unboxed method. But when asked if it'll be reliably put together, they said, not my area of expertise. Why don't we start, so Six Sigma tracks down everything, tries to get it right so that it goes together in one piece. Why don't we start here? Tell me what's going on.
Well, it's really interesting you mentioned Volkswagen and all those thousands of engineers, because that's actually a similar problem. You've got too many people and too much complication, which is exactly the problem that you've got in a traditional ICE car with all the wiring, everything connected to everything else. So a really good analogy for people that don't know what's happening with software is, I know you've got children, haven't you? You're looking at the Model Y, it's just big enough. But if you talk to somebody that's had twins, they'll tell you that it's not twice as complicated to deal with one baby. It's 4 times as much, because every time one wakes up, they wake the other one up. And that's what happens in the software with those 6,000 engineers that Volkswagen had, or if you've got every wire connected to everything else and everything physically connected together. As you try and work through all the issues, every time you pull in one bit in the software or the hardware, you get implications all the way through the rest of the system. So that's where effectively Six Sigma came from, because that's a really heavyweight process for tracking all the issues, fixing them very methodically, following all the implications. And that's one of the reasons it takes, do they say something like 7 years to bring a new model of car out, traditional OEM?
The life cycle, yeah. If you start today, you might get it out in 3, but 3 to 5 is the minimum.
So, and that's part of the reason, because every time you touch anything, it moves everything else. Even in the physical sense, if you make the car a little bit longer, the brakes, all the wires change, for the brakes, all the hydraulics, everything changes. So you've effectively got this giant loop. In fact, I need to congratulate you on a couple of your videos that I watched in the past where you went to see the car shows. And you were incredibly perceptive, because you talk about the windows. They won't wind down. They won't physically fit. And this is another one of the major issues that software people over the years, because of all these complications, have realized you need to fail fast. A prototype is a failure very slowly. Why
Wow.
spend 2 years before you then say, well, we can't do it, and then have to start again? It's crazy. So we often hear Tesla talking about various people, how you put all the people in one room to fail as fast as possible. So the designer draws a picture, but straight away the engineer says, no, we can't make that. So you go around the loop. Next time through, the engineer says, yeah, we can do that. But the guys that build the machines say, oh, but I can't build a machine that does that. So you want to go around this really tight, in software terms, an agile loop, get to the end point as fast as possible, and then, you know, and as Elon says, they don't build prototypes that they're not going to actually release. They know that they're working. They know that everything flows through all the way the design, right the way to the machines.
So in Microsoft Word, for people who've never done engineering, we can say that imagine if 10,000 people had the ability to move that image by 1 pixel, and now the entire document is screwed up again. And that would create some stacking issues. The more, you know what they always say, the more cooks in the kitchen, the better. I'm pretty sure they don't say that. So for software people, the whole point of modularization is to remove complications across the whole product by explicitly defining interfaces between modules and rigorously adhering to them so that the modules can be built independently. I need to make sure my door switches work right. That way I don't have to test it again later. And then, of course, we have to make sure the door switch talks to the rest of the car right. Get all the pieces working independently and hopefully together. We might even say that hardware benefits of easier build modular manufacturing just falls out of the software-derived principles. How so?
Those software principles of breaking things into modules becomes essential with software when it gets very big. We used to talk about system tests far more in software years ago. In fact, I worked for a company. We got a whole department of people that had only ever delivered software that was never used, because it took so long to deliver it that the world had moved on. So you need to actually have all those independent modules that can be reused as fast as possible in the new world, and everything can be done independently. In fact, there's a connection there, because that company came out of, and I don't know if you'll know, British Leyland, one of the biggest English car companies, that became Rover, which you might have heard of, but it became Rover after it had gone bankrupt. British Leyland went bankrupt, and the software bit of it was spun out into a separate software company. And of course, most of its business initially was with the car company. I didn't actually get to work on car things, but there were people doing various big systems, and they'd come with a very large specification, spend 2 years building that and deliver it, and then the world had changed. So we need to break all those pieces into modules to reduce the complications across the modules, because as we saw with babies, 2 of them are 4 times as hard. Imagine you've got 10,000, it literally becomes exponential, blows up. So nobody can hold that all in the head at once, which is why you need this huge big system to track all the issues. Nobody really knows what's going on. Nobody really knows all the different pieces. But if you work on modules, each team can deliver their bit reliably. And then with fixed interfaces, you know that it's going to work. We've seen Sandy Munro break apart Teslas. When he gets a Model Y compared to a Model 3, some of the pieces look very similar, but they're a new version, but they still plug in to where the old one did.
Yes. And they found that with the Plaid they tore down, that it had a lot of 3 and Y components in it because they work. I don't need to make a new FSD chip, a new, if you can keep parts in common once they're working, why would you? If it ain't broke, don't fix it.
And that applies all the way up and down the car. So the small modules, the light switch, the motor, but they were stuck with the whole car because of the wiring. As you say, you couldn't modularize the whole car. You'd got all these patterns. So we've seen through history that they've worked through structural battery pack, castings, unboxed takes us to the point where they literally separate modules.
And everything we've seen since really the introduction of the first Model Y has been a step towards unboxed. We didn't necessarily recognize it at the time,
No.
but when we saw the structural battery at Berlin's open house with the seats already mounted to it, to me that was a light bulb moment where I got it. I got it. No more climbing in if we don't need to. And that makes the job easier. That makes the time quicker. That makes the processes simpler. That's the thing where Herbert Diess went out and saw Giga Berlin and said, we got this, we have got to speed up because they are doing things very different than we are.
And the same thing with Jim Farley saying that they've got all these different software suppliers. That if they change anything in their core system, they have to talk to all those suppliers. They've just got complication built. In fact, I was, as a teenager, 100 years ago, something like that, I had a train track, little Hornby train track. I don't know if, do you have them in the US, Hornby?
No.
Little model toys. 1979, they introduced the Hornby 01. It was a British company, but they sold into the US a little bit. They introduced control by wire in 1979 on a toy train. Prior to that, if you put two trains on the track and turned the voltage up, they both went faster.
Right.
But they put a control unit on with a little chip in each train, whatever they call the engine, locomotive, and you could control the speed independently. And of course, we then heard Sandy talking about how he tried to get Ford to bring in 42 volt and this kind of modern technology 40 years ago. At a similar time to toy companies could do it, but of course they'd already got too much vested interest, too much sunk cost in all of the different suppliers, all of the different. But of course, the longer you leave that, the technical debt in software terms, or design lock, I guess, in terms of the wiring and all the other things, the technical debt just gets higher and higher and more difficult to fix.
Right. And question I've had to field a number of times is, why did they do the Cybertruck before the compact? And one thing that I hadn't mentioned is getting enough 48 volt parts to make 1 million, 2 million, 4 million vehicles right out of the gate 2 years ago would have been an impossible ask. But getting the suppliers started on 48 volt with a lower volume, but still significant, gives them time to develop their new competencies in that field, get to the point where they can actually do it, instead of just, I need 4 million of a very new part and I need it now. And that would be potentially problematic.
So if we've got maybe 50 a day, 100 a day Cybertrucks for a while,
It looks
that's
like,
going to give that's going to give those suppliers quite some time to develop and iron out the kinks. So they could effectively be working on prototype versions at the moment until they lock in the designs of all those different.
Yes. And we've been seeing for the last week, every time the drones fly, there's 100 to 150 out there. So the ramp could already be a little ahead of where I was expecting. So we also know that when the software systems of a Tesla car is first turned on, it runs a check mode, checks as much as possible. All the sensors are convenient, not just for the owner, but for the vehicle. And it does as much testing of itself as it can. Tell me about that.
Because Tesla have been busily writing their own controllers, as we saw, I forget the numbers, but Model Y 80%, Model 3 something like 60%, and the new unboxed model will be 100%. Even in the Model Y, even if it was wires, that central computer could check with all of those control modules that they've written, potentially some of the others, but that gets more complicated because the architecture, the communication protocols might be more complicated. But it can effectively, when it wakes up, talk to every window controller, say, are you there? Are you working? Are you doing? So at the point that a Tesla car rolls out of the door, it's had a lot of testing in what the software people would call a system test. You've finally checked all the things are different working, everything comes together properly. And if one of the window controllers doesn't respond, you know you've got a problem. You report it, you go and fix it.
Yeah.
Often those things with the other manufacturers don't actually get reported until the customer gets it, which is much worse.
Mm-hmm. So in the software world over the years, people realizing that turning everything on when it was finished and doing a big system test was a pretty scary time. Yes. So better to build and test each piece as you go. including before any of the parts are ever combined together in the final product. And having worked in a metal fab shop, we would have a supervisor who would come around and periodically just grab the schematics and use his calipers and double check everything's still right all the time. It was spot checking. It wasn't checking every one. But of course, you'd like to test as many pieces as you can so that when it does roll off the line and you've got, a window switch error, let's eliminate as many of those as possible. To which you add, wouldn't it be nice if all the systems of a car could be tested like that before they came together, and the car operating system does that final test? So, yeah, why would you need a car testing harness that could test the whole parts? What would we need to have that? Any ideas of what you could do that would actually make that work?
Yes, sorry, I thought you were going to carry on reading. We already know that Tesla are doing more testing at a low level than other manufacturers. The other manufacturers don't get a test till much later. Like you say, they do spot checks. We already know Joe Justice talks a lot about how a lot of the parts are tested, but when you start combining them into modules, it starts getting more complicated. And of course, those electrical components are not powered up till later, until you connect it to the power. But if we could test every module as it combines, we're literally testing all the bits. So every time we know that one module goes forward and combines into a bigger part, everything is working rather than waiting until the end. So we could immediately reject anything. It might be a bad connection between two parts, as well as the individual parts not working. So we know as we progress through the line that it's all working all the way through. We're going to get almost 100% reliability by the time we get to the end.
So because they're so integrated, not just writing their own software, writing their own standards, and controlling more of their supply line than many of their competitors, you say we would need a Tesla OS computer ready to run the tests. Check every Tesla has one. Oh, wait, the system is modular and the computer is in the front module and not even powered up yet. So can't use that. We need an external spare computer powered up and ready to go. I don't know. Does this have a computer in it?
And is it running the same 48-volt architecture with the same Tesla operating system? So effectively, that's very much like the central control system in the car, already powered up. And even after I'd written it, of course, you could actually work wirelessly. So the bot would only need to pick a part up, and it could literally be talking to the car, all the components, all the way through the process, making sure everything's behaving. Somebody said you wouldn't want to do that because it would use too much of the bot's computer, and it needs it for walking. But actually, the testing you do at this level is tiny compared to what the FSD is going to be doing. It's literally going to say to the switch that does the window, can you go up, can you go down, do the sensors work at the top and the bottom? Trivial tests, but the fact that you're doing them all the way through the process means you're going to arrive at the other end. So, and then another person would say, well, but why don't you build that into the sledge, whatever you would call that robot that carries the car around? And then when I started to think about that, but that sledge is for a car of a particular size. What if we make him bots?
Yeah.
The bot could help build more bots or HVACs or whatever else you happen to be building with the same 48-volt architecture.
Yes. He could also have a little sticker dispenser that leaves it. He could print it out and put it on the windshield telling you so that there's no confusion what's missing, what's going on, or even just make a visual cue. Obviously, all the data would be stored digitally because everything is, including parts locations in the warehouse on wheels. And that's another thing where digitization has really stepped up because we no longer need a shelf just for blinkers. We've got the exact amount of space we need at the exact amount of time. We just don't know where it is without checking the computer first. So there's a lot of possibilities here that a lot of people maybe didn't think of. So to get to the unbox method, it wouldn't just be possible, it would be potentially substantially better than the way it's done before. It could have a lower failure rate because everything can be tested along the way, and because we just so happen to be at a convergence in time where technology allows us to have a wandering diagnostic bot walking down the line and doing all these tests. Did I get it?
Absolutely. And if we take that one step further, in a factory, that bot is probably talking to the control center. So
For
we've
sure.
now got live data on every car as it goes down the line, what's working, what isn't, any issues starting to arise. So we've got a live monitoring system for the whole factory. Well, they have anyway to a point, but it becomes much more interactive.
Yes. So we know that this car coming that'll be at my station in 20 minutes is going to need a different door switch or something. It's going to need, we know what's going on with it, and we will be ready for it. That is a pretty crazy set of ideas, pretty crazy time to be watching this all happen. You have to wonder how much money this is going to save in terms of repairs, in terms of end of line delays, and then divide it by what the bot costs. And I think you're going to see that this is a tremendous opportunity to streamline in a very affordable way.
And even when we've got repairs, something goes wrong later, a bot is got all the software in it to diagnose any problem in any of the control systems. So the bot goes with the repair guy, just walks up to it and says, that's what's wrong with it.
Especially if it's wireless, he can do it standing next to within Bluetooth proximity, I imagine, or Wi-Fi proximity.
One thing we have to be very careful of is security, because we don't want somebody hacking that system and turning your plaid on and driving it off the drive automatically. So obviously we've got to be careful on the mechanisms for communication, make sure it's locked down. It might even need to be a physical connection just for security reasons, but I'm sure Tesla will work it out.
That's very easily done. We know how to make a physical connection. I'm less worried about that. I'm sure that will be well considered before we get to that point. Guys, if you're not following John on the old X platform, maybe you should be. He's got some pretty interesting insights, and he has already agreed to come back and have one more discussion with me about the state of robotics, because it's a topic that folks seem interested in. My question would be, what did we miss? What did we misunderstand? Leave it all in them comments below, and stay tuned, stay juicy, and I cannot wait to hear from you clever, yes, robots, on the flippity flop.